Does it factor nicely? How many of you are going to use the factoring like negative 0.702? No, we're not going to do that stuff. It's not a nice one at all. So we have to use quadratic formula. And remember, the quadratic formula is right down here. Ax squared plus bx plus c. So your a is this number right here. Your b is this number right here. And your c is that number right there. So a is 1, b is negative 5, and c is negative 4. If you do not get the quadratic all to one side set equal to 0, you can't use the quadratic formula. A, B, and C. And you need to go in what we call descending order. X squared has to be first, x has to be second, constant has to be third. So when I go to write the quadratic formula, negative of the negative 5, a lot of you would simplify that right away to just 5, that's fine, but I'm putting negative 5 in for b, plus or minus the square root of b squared minus 4ac all over 2a. Does anybody want to come up and sing into the microphone? That's all?
No.
Anybody? Sorry, I forgot to hit the pause button. So there's your answer. Okay, so what we did is we went through the quadratic formula. Again, be careful with all the negative signs. But anyway, square root of 41 is prime. You can't factor it. You leave it like it is. All right, system of equations. Really, in pre-calculus, we don't tell you how you have to solve systems. There are lots of methods that you can use. Typically, we want to see an algebraic solution, though, so you're not using your calculator to do some sort of intersection. We use that to check. So what I'm going to do is I'm going to skip the graphically, and I'm actually going to do the substitution first. So I'm going to do substitution first. And what I would do is, if I would take the bottom equation, I'm taking this one, I'm going to take the y to the other side. So that's really easy for me to get that x all by itself. Right? And so substitution then, I'm going to substitute the purple into the top equation, which I'm going to write in green. So I'm going to go 3. Now instead of x, I'm going to write 2 plus y. Plus 4y is equal to 34. That's why they call it the substitution method. You substitute out one of the variables for something that you've written in the other equation. So our first step as we solve this is to distribute the 3. So I get 6 plus 3y plus 4y is equal to 34. I subtract 6 on both sides. So I have 28 here. I'm going to combine these like terms into 7y. Divide by 7. Y is 4. When you solve a system of equations, you need to find both answers. Right? A system is asking you, when do the two graphs or two lines or two equations intersect? When do they touch? Y equals 4 doesn't tell me anything. We have to find the x. So take this y is 4, plug it into any of the original equations. I'm actually going to plug it right back here. And this says x equals 2 plus 4. So my x is 6. So that's my answer. So there's my answer. We did it by substitution. If I were going to check this answer, you could go to matrices. That's in that general form. The matrices work really nice. But if I were going to take this and put it into y equals mode, what do you have to do? You have to solve both of those for y. So this one, if I was going to solve for y, would be y equals 34 minus 3x. So you take the 3x to the other side. And then we have to divide everything by 4. So what I've done in red is I've written it how you have to type it into the calculator. The bottom one here, if you send the y to the other side like we did, then you have to send the 2 back. So this one's going to be y equals x minus 2. So let's type those into our y equals 34 minus 3x 2. And let's see what happens. Parentheses. 34 minus 3x. Yes. 3x divided by 4 and x minus 2. I have to redo my window, zoom 6. So you can sketch that graph in the box provided. Second trace to calculate the intersection number 5, enter, enter, enter. 6, 4. It took me approximately 30 seconds to check my answer. And then quickly by substitution, 3x plus 4y equals 34, x minus y equals 2. What would you do if you're going to do this by elimination? Did I say it? Oh, man. Yeah, we did. Linear combination, so go down to the next one, slash elimination. Some people call it elimination. Let's see if it'll let me. Oh my goodness, what's going on there? We don't want to do that. I don't know. Okay. What would you do if you were going to do linear combination or elimination? Do you like to subtract? Is that what you do?
It's easy.
No, you didn't do it wrong. I prefer not to have to subtract. So let me show you something. I would multiply the bottom by 4. Oh. I would multiply the bottom by 4. So I did not change the top. Multiplying the bottom by 4, change this, so that's 4x minus 4y is equal to 8. Now, I know that some teachers in the past have told you get the numbers to be the same. So Andrew said multiply by 3. So he'd have 3x and 3x. So they are the same. Oh, well, some teachers teach them get the things the same and then you subtract. But the problem with subtracting is you guys tend to forget to subtract everything, or when you subtract, you're bringing a ton of negatives into it. So I prefer to actually do linear combination. By getting them to be opposite, I can tell right now that these are going to be gone, and then it's just a matter of squishing the other ones together. So 3x and 4x is 7x, 34 and 8 is 42, divide by 7, x is 6. Bring that back to one of your originals, so we could go 3 times, instead of x, I can put 6. And then we solve this. 3 times 6 is 18, so when I subtract 18 on both sides, what does that give me? 16. Divide by 4. So I still get my 6 and 4. I prefer to get them the same. So I teach it more of a linear combination because you're just squishing them together. And that's where some people do call this the elimination